In this video, I'll be going over how to create this design. This is a building that has a ramp that surrounds the entire building. We also have an inside space and a circulation core. I'll be going over all of the steps in detail here. So thank you very much for being here. So the first thing we'll do is type in units here inside of Rhino, and let's work with feet and then feet in inches. The reason for this is going to be a fairly large structure, so feet would work, but honestly any units that you use would be fine for this design. So now let's move on here inside of Grasshopper. I'll create a new document, and now I'll go here and create a point. So I'll go here to construct, point, and this point I like to route it through a point component. This way we can change the location of the design. And now we can start here using this reference point to create our base form. I'm going to be creating a rectangle, and so we'll go here, double click, and we'll bring in a rectangle component. For the plane, we can plug in the point into the plane, which means that that will be the location of where it's started from. And now let's change the X and Y size. I'll double click and bring in a slider. I'll type in 12. And now I'll take this and actually create a copy because I want two separate inputs for the X and Y. This is going to be the center core of it, which could house the elevator and the stairs. So we'll keep it here so we can change the dimensions. Next, we'll move on to basically creating the base curves for where the forms are going to go. So this is going to be the elevator. Now we're going to offset another line to kind of create that building inside space. So we'll take this and we'll go to offset curve. We'll plug in the rectangle into the curve input. And now the distance, that's going to be the offset amount. So I'll take this, slide it over, tap Alt, and create a copy. So I can just kind of quickly create a slider that's just copied from that original one. And now we have this space that has been offset by that specific amount. So we'll go here to 30. And so that's the building. Next, we're going to be creating the ramp area. So we'll basically be doing this again. So I'll take this, slide it over, tap Alt, create a copy, and now I can plug in this curve into this offset. And notice that they maintain, so we'll have 30 here, but it maintains that even though we're changing the slider on this one. So they're all kind of depending on each other as we kind of go down the logic here. So with that being said, 30 is a little bit too much for the ramp. So we'll kind of decrease it here. Maybe this is a little bit too much for the building. And lastly, we're going to be creating a slope form for the ramp. So I will be taking this and offsetting this again. So slide it over, tap Alt. And now this is going to be where the form will be subtracted. So what I'm doing here is basically creating, with this logic, some base curves that will determine the minimum and maximum of the elevator, the circulation, then the building, the outside circulation, and then lastly, the subtraction of the form using the space between these two. And of course, this will make more sense as we kind of go along. And so for now, let's start by creating the elevator tower. What we'll do is we'll go here back to our rectangle. Now we're going to turn this into a surface. So I'll double click here, go to boundary surfaces. And now we can extrude this to a specific height. So I'll go here to extrude. In which direction? Unit Z. Because when we extrude something, it's going to ask us for our base geometry, which is going to be the surface that we want to extrude, and the direction is going to be a vector. So it has a z vector, so basically going up, and now we can plug in a value. So I'll take this once again, tap Alt, create a copy. Now we're creating the building height. So now that we have that base form, we can move on to creating the floors. As you can see, we have our base rectangle, and we have our offset rectangle. Well, we need to create a surface between those two. The way to do this is to bring in a boundary surfaces. And now we can plug in both of those, holding down Shift to add another input, and flattening the input. This way, it only creates a surface between these two. Otherwise, it will actually overlap them, and you don't want that. So now with this base form, now we can create the array for the floors. So we'll take this, we'll go to a move component, and we'll also bring in a series component. This is the technique that I use to create an array of copies of any object. What we'll be doing is taking this, copying it up vertically, using a specific amount as the step, and then being able to pick how many we want to copy. So we'll take this surface, and that's what we want to move, so we'll plug that into the geometry. Now we do want to move this up in the Z direction, so I'll double click here and bring in a unit Z. Now I can plug in that unit Z into the motion and see that I can plug in a value for the height. So I can say 12, copy this 12 feet from the first one. What happens is, since this is only one number, we want to create a series of numbers that steps by 12. So I'll plug in that 12 into the step, and I'll unplug it from the Z vector, because now we're creating a series of numbers stepping by 12 and creating a default count of 10, and we can change that. So let's plug this into the Z vector, and it's created 10 copies. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we want to change the count, well, here under count, we can say 5. And now we can change the number of floors that we have by using the count slider here. And the step is going to be by how much. We'll go here at 5. Okay, so we basically created the inside circulation tower. Now we've created the floor, and we're working with base form, so we're working with just surfaces. Now we're going to be creating the fun part, which is going to be the ramp. There are a few techniques that we'll go over that will be super useful. And then we'll be moving on to subtracting the form of the ramp to kind of give it more of an architectural design, and also to create more variability within our parametric design. So we'll be moving on to that right now. All right, so at this point, we're going to take these lines, so between this one and this one out here, and that's what we're going to be using to create the ramp. Now, the reason why we have this line here is because technically we only have a minimum distance for a ramp, and this leftover portion is actually going to be for subtracting the ramp, and you'll see that in a second. So let's create the ramp between this line and this offset. And to do that, we're going to start by selecting this line, which is the offset from the inner core. We're going to explode it using the explode component, explode curve. This is going to explode it into segments. So it has 4 different segments. Now we're going to take one of those points. So we have line segments and we have vertices, which will be these corner points. I'll go here to item or list item because all of these vertices are actually inside of this component. And to just pick one of those points, we need to plug in the vertices into the list. And now we have just one of those points. And when I hover here, it says 5 points. And here we only have 1 point. We need this point to then move it in the negative Y direction. And I use this widget here inside of Rhino to guide myself as to which way I want to extrude. So we'll take or move something. So we want to go negative Y. So we'll take this point and we'll move it in the Y direction, but in the negative. So I brought a Y vector, negative component, and I'll plug those in. And now I'll be able to take this point and move it in the Y direction. So I'll take that point, put it into the move component, and now this negative is going to be plugged in. As you can see, we don't have that specific distance into the factor here. So what we need to do is to figure out what that distance is. And it's nothing more than, let's see here, 11 plus 11. Because from here, we offset by 11 and then 11. So we do a mathematical addition. This way, because we know this can change also. And so can this. So we have to make sure that these two sliders get added together. So we'll add 9 plus 11. And it doesn't matter the order here. Now we can plug this result into the factor. And this will make it so we move that point exactly to that specific location. And when we change the sliders, it will keep it there. The reason for moving that point was once we have 2 points, now we can create a line segment between the start and end point. And with this line, now we can extrude it in this direction and create the ramp that will actually be going at a different frequency than the floors. So we'll take this, and now I'll actually need to know how long this segment is so I can extrude or move this line all the way out to here to knowing that specific length. And so what we've done back here is we exploded it. Well, if we exploded it, we can select one of these lines. So I'll go here to list item. And this time I'll actually be picking one of the segments. And coincidentally, or not so much, is that that first point is actually the first point of the first line segment. And when we pick the first line segment, it's actually the same as this one. So what's cool about that is now that we have one line segment, well, we can extract the length of it. So if I go here to length, and then bring in quotation marks for a panel, we can see that in here we have 94. So that's how long this segment is. So that's how far I need to move it in that direction. Now, what's cool is that a motion you can plug in a vector, and a vector can be a line segment. So we can take this line, plug that into the geometry and the motion. Well, we can just plug in that line segment. But it's actually, yeah, it's not working. So we're actually going to have to move it here, looking at the widget in the X direction. Now I'll plug in that length into the factor because that's by how much I want to move it. And we'll plug in the X vector into the motion. So now we've created this line segment, and all we need to do now is lift it and raise it up to create a slope. The other thing that's important is understanding and knowing what the slope percentage is. And this would be for people that are of determination, is they would want to access the ramp and be able to use it, maintaining, the minimums and maximums of ramp requirements. So we'll do that. We'll make sure to take this and move it up. So we'll take this line segment, plug that into the geometry to move, and we're going to be moving it up in the Z direction. By how much? Well, we can just say 1.500, and we'll move it up by that amount. Now I'll disable the preview when it was kind of here on the ground, and now I can create a loft between those two segments. So I'm kind of organizing things here. So I can bring in a loft component, and this would be similar to what you would do inside of Rhino, is take this first line, we'll move this down, and then hold down Shift, add another input, and now we've created the ramp slope. With this ramp slope, now we have the basic segment to rotate around and move up vertically. So that's what we'll be doing next. And then I'll show you how to create the landing. So there are a few techniques here that are a little bit confusing, a little bit tricky if you're fairly new. But if you stick with me and you work through the steps here, I'm pretty sure you'll be able to achieve everything without any issues. So let's move on to creating the array and then moving them up vertically so we can create the ramp. For this technique, we have to make sure that our building is actually square. So for now, we'll take this slider and we'll plug both 26 into the X and Y. And the reason for that is because this circulation system is going to be symmetrical. So we want to create a center point so we can rotate this around. And that only works if it's perfectly symmetrical, which means it would have to be square. That's for this example that I want to keep fairly simple. There are other techniques that I can show you later on in other tutorials where we can break that symmetry. There are a few more steps involved, but they're also really useful to know. So for now, we'll take this and we'll go to our tower, which is up here. And we want to get the midpoint of this tower. So I'll go here to an area component, which will give me the center point of any object that I create here. So I'll take that extrusion, plug it into the geometry, and the center point, this centroid, is what I'll be using as my rotation point so I can rotate this around the building. So I'll go here to rotate, and there are different ways to rotate. We'll be using just rotate an object in a plane. The centroid will go into the plane. The loft will go into the geometry. And automatically it copies one because we basically rotated it once. Now, if we want to rotate it more than once, well, this is where we need to bring in a series component in the same way that we have a series component here. We'll go to series. The step is going to be by how much it's going to step, so 90 degrees. Count is how many, so we'll pick a slider, we'll just say 15. And start, it's okay if it starts at 0. The important thing is when we rotate using degrees, we do have to change this angle to degrees so it works correctly. And now we can plug that in and see that we've actually created a bunch of copies. Now what happens is, since we're creating them here all on the same level, well, they're all overlapping. So what we need to do is, to make sure that they don't overlap, we need to take these and do a series of movements up by the same amount as the slope height. So we'll take this and we'll go to a move component. We'll plug in the geometry in. The motion, we'll go to unit Z. And we need to bring in a series component once again. And this time, well, we know how many copies we want because we want 6. So we do the same amount of copies as ramps that we have. And the step is going to be the amount that it's going to go up by, which is this number. Now we can plug in the series into the factor. And notice that now all of the ramps are moving up progressively by that same step. So now what I'll do is I'll take this one and I'll disable preview because we're seeing the old ramp. And now when we start here, it ramps up, then it moves up by that amount, then it ramps up again, then it moves up by that amount. So now we can add more ramps to work our way around that design. And it kind of works independent of the building. This way you can either start or stop anywhere before or after, right? So in my opinion, that's a really neat trick. The only thing is that now we don't have a landing here. So we need to do the exact same thing that we did to this, but we need to do it to the landing. So what we'll do is disable the preview on all of this. And we'll go back to this loft. Now remember that we have created this line segment to create this ramp. Well, we are going to take that line segment and we're going to extrude it in the X direction by the same amount as that this is between those 2 points. So we'll go to extrude in unit X. Wrong one. Oh, that's right, unit X. And now here we're going to plug in that same addition here, because that's what we use to move this point. So this, the result of those 2 offsets will be used to extrude the landing. This will cause one issue, and you'll see it right now, is that if we were to, so we'll slow down here a little bit. If we take a look at our final design, cool, this one fits here. Now we just need to rotate it and move it up, rotate it and move it up, and do that over and over again. So what if we did that? We took all of this, copied it down, tap Alt, and now this extrusion will be plugged in here to rotate, and then it will create the landing. So that's basically, we copied the steps here and we copied them here. The only issue it causes is that now we don't have, let's see here, you got it all here. Oh yeah, that works. Okay. So with that, the only thing is we don't have a landing here at the start. So we can go back to, which we don't technically need because here we would be at the ground plane. So whether you want that or not, that is something that we can add. But so I guess that issue would only come up if we extruded this one, which means that it wouldn't do the last landing. But if we do this first one, then it does. So now we can take all of these the ramp, and kind of move it up and down, and it will move up and down with it. And it's going at a different frequency than the floors. So it will intersect in some points, but it won't in others. Now what we're going to do is take those two separate surfaces and we're going to join them together using brep join. I'll flatten the input just to make sure that here as the output we only have one open brep. And then I'll disable the preview on that. Cool. So here for the first one, we have 8. We'll bring this to 10. Okay. And so now we'll start creating the solids. Because the distance between these two lines, these two curves, we're going to be creating a slope to cut away the ramp. We'll take this, we'll go to extrude, because we want to extrude this up to give it some thickness. We'll go up in the Z direction. Now I'll disable the preview on this. And now we've basically extruded the ramp. We're going to do the same thing with the floors. The cool thing, we already kind of have it taken care of here. Now, obviously, the factor is going to be important if we want to change how thick the ramp is going to be. And we'll do the exact same thing to the floors. So I'll copy that down and I'll bring in our floor arrays, which are here. Here. I'll take the geometry output and plug that into the breps. Actually, this is brep join, so I'll delete that. This is called a relay. When you double click on the wire, it brings something called a relay. And sometimes you can unplug it here and then plug it back in without having to go back, and then you can select it and delete it without having to go back all the way to the original, which it's not a big deal, but sometimes you can save a little bit of time this way. Okay, now we've created the floors. Cool. So now at this point, we're going to subtract from the overall form. We'll take from these two, we'll first bring in a move component. We're going to be moving this line here into the geometry. Now we're going to move this up. So I'll go here to unit Z and plug in a number for the vector. So I'll go to 150. Next, I need to create a slope between this one and that one. So we'll easily create that by going to loft between this line and this line. That's actually incorrect. It's actually this outer one first, and then I'll hold down shift to add this one. Now I'll type in flatten for sure. This way it works. Otherwise, sometimes when you create an offset or a move, they have an issue lofting together. But now with this, we can take this outer line, move it up by that same amount, and create a solid. So you'll see here that I'll take this outer line and I'll move it up by the same amount. So I'll take this, tap Alt, make a copy down here, and we'll take this curve and move it up also. Now I can do another loft between the outside one and holding down shift, the additional one. And now I can take these two and join them together. So I'll go to join, VREP, and holding down Shift, I'll add both of those and then flatten the input. Then I'll disable the preview on all of this. And now we can take this and bring in a cap poles, which will give it a top and turn it into a solid. And now with this, we can take that and subtract it from our ramp. So we'll take this and we'll go to a solid difference, and we'll subtract VREPs B, which would be this solid, from our ramp. Now I can disable the preview here, and let's go to that loft. And now the ramp is progressively going in as it goes up. And this is determined from our offsets here. So the more offset we have to the outside, the more of a slope we'll have to the inside. And also if we bring back our loft, we'll be able to see that this would technically be part of the skin, right? We can bring this up here. And if we make it low enough, it actually won't, it will overhang at some point where the ramp, the useful portion of the ramp will be here, where there's enough for people to go up and down. And then here it could get wider. So those are some of the cool things that we can do exploring here a parametric design. Let's go here to 100. And we can even tie it. So right now it's at 100. And we can tie it to the same height of, so here, this one. So unit Z, we can plug that into this one. And actually, what happens is this unit Z should be not the Z vector, because it's a Z vector going into a Z vector, but it'll go 100 going up. And so that is kind of the conclusion of the overall form of this building. The idea was to create a building form that we can change the size of. So that's going to be the center core of the building, which can house the circulation, let's say, of an elevator and stairs. Then we have the building form, which is going to be the usable workspace between the elevator and the ramp. And then we have the ramp, which is determined from the initial offset and then the additional offset as it tapers down as it goes up. And now lastly, what I want to do is create some walls to create the enclosure for the building, then create some openings that will be aligned to where the ramps are going to be. So those are the two things. The other thing I want to show is, let's go back to the ramp and let's add more segments to the ramp. Now we have this ramp and we'll add more. Because I feel like it would be neat to have the ramps possibly go a little bit higher than the building itself. 37. Perfect. Okay, so now with that, let's disable the preview on the facade. It's going to be this loft back here. So I'll do Control G to kind of create a group. Now this is in white because I changed the default color. And you can do that by right clicking on the group, go to color, change it, and then make that your default color. Now, what I'll do is let's focus on creating what we talked about. But let's also notice that we are previewing some stuff that we don't need to look at, which is this. Okay, so now let's create the walls. Now, to create the walls, we need to go all the way back to this base curve, offset it to the inside, and extrude it to the same height as the walls. So we'll take that, we'll bring in an offset curve. I'll bring in that offset curve into input, and it's offsetting to the outside. I'll go here to a negative component. This way we can change the direction, and we'll go to 1.5. Now I can add that as the input. So we'll take these two and create a surface between those. So I'll go here to boundary surfaces and plug those two into the input, and then right click and flatten. This way we create the surface between those two lines. Now we can take this and extrude it using an extrude component, and we're going to be extruding this up in the Z direction by the same amount as the walls, or as the floors. So let's go back to the floors, and let's take a look at what we have here. So the extrusion is done after we did the array, which is here, and it's telling us that we are stepping by 12 and we have 8. Technically, that's a multiplication because we have 12 feet times 8 floors, and that gives us 96 feet. And that is what I can use in the unit Z to extrude up, and I'll plug that as the input. And the walls will be going all the way up to the last floor. Now, if you didn't want it to go all the way up to the last floor, what you would do is, rather than 8, you'd do -1, which is actually what I want to do because I want to have a roof, open roof deck. So we'll do -1 and then plug that into B. And so now we've gone all the way up to this floor, but not all the way up to here because I want to have access to this area and for it to be more of like a lookout design. Great, so now we've created those walls, but what happens is, oh, the other thing, here's one thing that kind of slipped my mind because we're trying to cover a lot of information in a short amount of time. When we create the slope ramp, this is going to be how much it's going up by. So if I said 1.5, the ramp is going up 1.5 from beginning to the end. And the way to calculate what the ramp slope is going to be, so let's say if I change this to 5, the way to know the slope of the ramp is going to be rise over run. So 5 divided by run, and that's going to give us a percentage. So the run is going to be the length here. So when we take a look at this curve, we know the length so we'll divide it by the length, either out of the panel. I actually like to do it out of the component. And that gives us 0.03, which we do a multiplication by 100. I can do by 100 on a slider, or I can just type in star or multiplication. And that way I can just do by 100. And so in B, we'll get 100. And now when I bring in a panel, it will take it into a percentage. So 3% slope. And when we're talking about a slope, let me see here, 3%, we'll do 1 divided by 12, which is 0.08, and that's the maximum. So if we do it over, we move this over a couple, it's going to be 0.08 that we don't want to go over. So now here, it looks like we're probably okay if we increase this to more. So what we need to do is now go back to the spot where we have our ramp, and now we need to decrease the count because we have too many copies of the ramp. So let's go back here. This one. Something like this, where we can go up the ramp, make sure that it's within. So we have, let's see, going up 5 feet from beginning to the end. The length is rise 5, run 137. That gives us this percentage, which means that we can actually probably go up more. So what I'm seeing is that we can probably bring this down a lot more just to make it comfortable for people to kind of walk up, and we'll use that as a parameter to make sure that we're kind of good here. Now we're going to move on to taking the outside wall. So we're going to take this ramp, we're going to disable the preview, and we're going to bring back our original ramp, not this one. Which was a joined brep. And we're going to also figure out where that intersects with the wall. So where that intersects with, I think we have the wall up here, then we want to get that location. So we'll go here to intersect at the top, then brep with brep. Now we want to plug in the walls, and then plug in the ramp. And so that gives us that spiral that then we want to intersect. Let's see here, with the floors. That's what it is. So now with these, with this line, we want to intersect it with the floor. We'll go to intersect brep with curve, and we'll plug in this curve into the curve input, and the brep is going to be the floors. So that is what we have here. Right here. What we'll do is we'll take this all the way out here. And my apologies, it took a little bit to figure that out. So where they intersect, where the ramp intersects with the wall, we get a spiral curve, where that curve intersects with the floors, not this one, which are these, then we have a point. Now what we're going to do is where that point is located, we're going to create an opening. So we'll go here to a cylinder. And where those points are located around the building, which they will vary depending on the slope, frequency, and those kind of things. Now we can take this curve, plug that into the base. Then the radius will be the opening size. So we'll go 10. And then the length, which is going to be the height. I'll do 10 again. So I could have just copied that. Let's plug that into the length. And now let's flatten the input because I think, not graphed, flatten the input. And it's because I'm using the curves. It actually has to be the points input. Now we can take the points where they intersect and subtract them from the walls. Now notice that these cylinders are open, so we do have to type in cap holes and turn that into a solid B-wrap so we can subtract it from the walls. So I'll go here to difference, solid difference, and we'll take the go here, the wall, B-reps A, and then into B-reps B will go the cylinders. And I'll disable the preview on this. And let's go back and disable the preview on a lot of things that we don't need anymore. Now we'll go back here, disable the preview on this one. We'll disable the preview on one, and we'll bring back one. So now we can see the openings here. Now there, I will be doing some modeling afterward to create a rendering to show what this can possibly do. And for me, the cool thing about this design would be to share it with people that are of determination, or people that are in a wheelchair or can't really access buildings like this. This would be a really cool place for you to be able to walk up, have some area on the inside for maybe shops or something, and then up at the top you can have a lookout point. There's actually one last thing I do want to do, and it's the railings for the ramp. I want to create a railing on the outside for the ramp, and I do want to do it parametrically, so I'm going to give that a shot. And the way to do that is going to be the same way that we did the intersection here. We're going to see where the ramp intersects with the lofted form. So we did have a lofted form that we're not previewing, which is this one, and where that intersects with the floors, which would be here. So I'll take this and I'll group it because I want to remember that one. So that is the ramp, and we're going to go back and look at where that intersects with this. So intersect, or under the intersect tab, brep with brep. We'll do that ramp or that slope into A, and then into B, we'll do the floors. Now we can basically disable the preview on both of those, that and basically the curve will disappear, but now we have it here. So let's take this and bring in an extrude, unit Z, and then I'll do 3.5. Plus the floor, because it's starting from down here, so it's got to be plus the floor thickness, which is here, 1.8. Now we can use that output for the vector, and we have created the railing for the building. Of course, we would need a structure for this, right? Like, how is this going to overhang all the way here? But those are details that we can get on into later. For now, I wanted to go over how to create this building form for those of determination. And like I said, I'm going to be doing a render to show what it would look what it would look like at the end, and I will put that as a thumbnail. So please let me know if you have any questions and if you enjoyed the tutorial. I know there were some places where it may have gotten a little bit confusing, so please ask me questions. I can do follow-up videos to clarify anything that I've done here that maybe didn't make sense. And I will also have this available on my website under the Script Vault membership. Thank you very much for being here. If you enjoyed the content, make sure to give it a like and subscribe for future videos. I make videos like this every week where I share the process for creating architectural and parametric designs using Grasshopper for Rhino. And if you want to get a hold of the script that I made for this video, check out my website capettidavid.com. There, when you become a Script Vault member, you'll have access to the video script and much more. I also have a script store with scripts that are ready to go, and you can also contact me there. And if you're brand new and have never used Grasshopper before, I would suggest checking out the self-paced workshop that I have on my website. Thank you very much for being here, and I hope to see you next time. So I've gone ahead and decreased the parameters to an amount where the building wasn't too overwhelming, in the sense that we don't want too many ramps, we don't want the building to be too big. We just want to be able to visualize what the script can do. And so what I'll do now is clean up the script. I'll do a time lapse of this so you can see how I organized it. And then we can go on to possibly doing a few more things with the script.